Namaste everyone. I welcome you all for our today's session on data mining technology. The outline of the lecture is that we will first try to find out what is data mining, what is its importance, how it is related to the present systems and challenges. Okay, and generally we will go forward towards the three key technologies and coming up how data mining and machine learning is interrelated. So this will be the outline of today's lecture. Since its introduction, we'll try to be a bit short and brief. So the agenda, data mining technology, the process, data preparation, data mining models. This we can cover up in our another presentation. Data mining techniques, that will be another presentation or another lecture. There will be one again separate lecture on data mining applications and tools, and another lecture on data mining methodologies. Since we will be going today that how data mining and machine learning are interrelated, ultimately a lot of data mining process, techniques, application tools and methodologies, they are used in machine learning itself. But why we are integrating these two topics? Because data mining is the most biggest challenge of the day. And as the name suggests, data means there are a lot of raw facts. So if you go to Google and you start searching on any item, you get lot of data. Okay, and mining means खदान में से निकालना, है ना? तो आप कोयला निकालते हो, gold निकालते हो, तो mining means we are trying to dig, and we are trying to dig it too deep. So in today's world, since data is too much, we need to dig the data into deep so that we know what we really want. Okay, for example, if you search about square, so square is a shape we all know, but there can be some square named company, so you will get the name of the company as well. Okay, you will get some lecture on square, you will get some different geometries on square, but exactly what are you searching? If you are searching that what is the meaning of square and you get a company named square, then probably that's not your requisition. So you need to be more precise. But we are so used to writing on Google that we expect that we get the data which we require. But is the Google that much intelligent? It may be, and that's why previously only text was being searched. Now even if you put an image as a search, you get the related images. That means the more the data increased, the more the search engines had to be made more intelligent. And those algorithms which made the search engine or the machine intelligent, they are called as data mining algorithms. Okay, so ultimately machine learning means you are making the search engine machine intelligent. That means you are feeding some learning process to the machine so that it can dig the data for you very aptly, and that is nothing but the data mining algorithms. Now you can take it as a homework that what is the difference between a process, a method, a methodology, a technique, a model, a prototype, an architectural diagram, what is an application, was it a tool? Okay, you can, since this is a recording, you can go back to the recording and write down all these definitions. Okay, this is the benefit of the recording, that you can rewind it a couple of times and write it down. As you saw that a model, prototype, simulation, system, these all things, architecture, these all things uh, looks quite similar. But since their names are different, obviously their dictionary meanings might also be somewhat different. Okay, so what is the difference you need to identify? Because as a researcher, okay, whenever you write a paper or a project report or a thesis, especially if you are a postgraduate student or if you are a PhD student, you should be able to clearly define. If you have written a model, then the model is a framework. Then if you are specifying a framework, then what exactly it is? If it's a system, then what's the data flow diagram? Okay, so whatever you are mentioning in your research paper or thesis, the diagram should be very, very apt to your definition of the diagram. Okay, you give a title to your diagrams, So if you say that this is the system diagram, the diagram should be visualized as a system diagram. If you say that this diagram is a framework, it should be a framework. So you can take it as a homework, that what is the difference between all these. And a lot of times when we are doing our study, we try to find out the definitions of what is a framework, what is a model, what is an architecture, and then we write it down and we get contented that yes, this is the difference, we got it. But I want you to take one single example, maybe whatever is your problem statement or mini project you are doing, or your the problem statement of your undergraduate uh, project report which you have already carried, or which your thesis, PhD thesis which you are going to carry out. So you take that problem statement. Of that problem statement, you try to analyze what will be the architectural diagram of this, what will be the system diagram of this, what will be the framework of this, what will be the prototype of this. If with a single example, if you are able to differentiate between these definitions, then you will be apt, uh, be able to clarify the exact meaning of those. So what is the technology? Now, if you, as we already said, that a customer wants to, you know, churn certain data. It wants to take out certain data. Okay, so for example, if customers receive incentives, say average cost of $160. So what you have to search this data from the entire database you have. So if you have learned database management system, data mining is the advanced topic of your DBMS. So this particular example of customers, department, employees, maybe if it's a university database, then you have student, library, then department, then faculty. Okay, and if you have a bank enterprise or a database, then you will have a customer, you will have the account details. Okay, so similarly, whatever you are putting in your table format, okay, that's called as a relational database. There are different types of database you might have learned in your DBMS, maybe hierarchical database, network database, um, linked database, relational database. So what generally we are using is as SQL, Oracle, SQL Server, even your MS Access. Basically, these are relational databases. Why they are relational databases? Because uh, as per the research, all the other types of databases, relational database is very easy to design, very easy to implement, and it's very easy to retrieve the data, create, manipulate, and edit. So we have got DDL statements, that is data definition language, where you have got a create statement, you have got a drop statement. Drop means you are dropping the table. Okay, you have got an alter statement where you try to alter the definition of the table. Then you have got a data manipulation language where you have, you know, uh, your select statement, your update, insert. Okay, these are the SQL queries which you use for your updations of your database. Okay, then we have got control statements, that is grant permissions, revoke permissions. You have got commit, rollback. So these are the control statements. So these are the basic database operations. Okay, but as soon as your table, if it is exceeding the limits, that means it's going about 1 lakh rows, 10 lakh rows, then searching the data becomes tedious. Why? Because your select query may require a lot of time. So you need to create such queries and such algorithms which in minimum time try to access your data faster. So if you go back to your basics, what is the what is database management system? Database management system is that you manage your data in such a way that you try to retrieve the data faster. Okay, so if you have a lot of clothes, the more clothes you have, the more it's difficult to access it when you actually require to, select a particular cloth for a particular function. Similarly, more the number of books, the more you need to sort it out so that a student gets the book faster. Okay, so maybe you can sort it out subject wise, maybe you can sort it out alphabetically. But what is data mining? Okay, now when the data becomes too large, you need to have specialized algorithms to find out. But it is more related to machine learning. Why? We need to understand first, what should we be fed to the machine so that we design the data mining algorithm in such a way, okay, so that we can retrieve certain special information. Okay, so there is a triangle diagram. Maybe in our another presentation, I will show you the diagram. That first we have got a lot of data. From the data, we get information. From the information, we get knowledge. And from the knowledge, we get intelligence. Okay, so for example, there are a lot of student data, and we want to find out the information that how many students have got percentage greater than 60. Okay, so that becomes the information. So there are 10,000 students, and out of that, maybe, say 1,000 students have got greater than 60. So what has become? It is a triangle. So data is the base. उससे छोटा आएगा information, उससे छोटा आएगा knowledge, okay, उससे छोटा आएगा intelligence. Okay, तो यहाँ पे examples it has been given as tarot cards. So tarot cards is one of the prediction methodology. Okay, so you might have heard about astrology where people predict. You have also learned about the uh, forecasting of the weather. So that is also one type of prediction. Even tarot card and magic 8 ball are also one type of prediction. Now, why this data mining in topics prediction has been introduced? Because prediction algorithm is one of the technique of data mining. But just to give you an introduction, that for example, in astrology, if you say that these people had so many characteristics in their horoscope, which made them recognize that they become very good singers. Okay, so if some after studying 10,000 case studies of the singers, okay, if suppose 10,001 person comes to you to see whether he or she can become a singer, you can find the similar patterns which you found out from 10,000 records. Similar patterns, if they are found in the 10,001 record, you can, you have a say accuracy level to say that this person has a chances of becoming a singer because he had got the similar characteristics which were found in the 10,000 records. Now see, 10,000 is a figure. The more case studies you try to see the characteristics, the more confidence level increases. Okay, so even a lot of people who are approaching this subject are basically going for health systems. Now, whoever had invented kerosene, okay, what he might have done, he or she might have done, he might have invented that kerosene, see, and applied it to say 10,000 people, or maybe 10,000 of species, or 10,000 of case studies, and or maybe he might have done simulation. After the 10,000 case study simulation, he found out that the fever got down. Okay, so if that was that case study was successful on 10,000 case studies or species, it was apt to be suitable to 10,001 case study also. In a very rare case, it happens that it is not suitable. Then you might see that that person has some other health characteristics which was different than the 10,000 key species. And see, in whatever machine learning or data mining, they are ultimately soft computing techniques. What is soft computing, hard computing? We'll take a separate lecture. So you will understand. And this again, the Croson example, so it is more easier for you to interpret. So basically, the why data mining became very popular because gradually the data went on increasing. And today, everybody is not only searching but uploading their data on the internet. Okay, people are creating YouTube videos, lectures, their documents, research papers, notes, and they are uploading. Now, sometimes when the data is too large, it becomes very difficult to get the most appropriate thing what we want. Okay, so for example, we have got only 10 dresses. To pick one dress from the 10 dresses is very easy, but to pick a dress from 10,000 dresses, okay, ladies can understand how difficult it is. So as and when the data is increasing, the algorithms need to be modified. So even today's search engine, people have done a lot of research on search engines for data mining algorithms. Still, this will go on and on and on, because this challenge is going to increase, because the variety of data is also increasing day by day. So this challenge is never ending. Data will never be going down, and that is why the need of data mining and machine algorithms will always be in need. So coming to the three key technologies, these are the slides from the Wipro company, because Wipro is the industry which is highly working on data mining and machine learning algorithms. There is a UCI repository site where, you know, a lot of data sets are there for researchers to explore their algorithms on. But those algorithms have maximum, say, 10,000 records. But if you want to actually explore on data sets more than 1 lakh, so you need to approach companies like IBM, Wipro, who are actually working on databases. Okay, so Wipro is one of the company. That's why I selected this presentation, which was shared to us in one of the conferences. So this is increased computing power. Okay, so since more the data, we require the algorithms in which you need to handle increased computing power. Okay, secondly, more statistical and learning algorithms need to be analyzed and implemented, and improved data collection and management. Okay, this is sometimes very much neglected, but this is the most important thing in my terms, because the more efficiently you arrange the data, it becomes easier for you to manage. Okay, so we will be learning algorithms for each of them, but ultimately, if you see, okay, this is statistical machine learning algorithms. This is also a part of machine learning. Okay, this is a part of DBMS. Okay, and this is also a part of machine learning, but ultimately they converge to data mining. So in data mining, we have two parts. Okay, one is called the OLTP, that is online transaction processing. So whenever, whatever data is coming online, so for example, in banking systems, every day there are so many transactions happening. Okay, so the data, you can understand how much large it is. But do you think that if so much large data will be handled even on clouds, somewhere memory has a capacity, and not even the capacity, if the data becomes large, the accessing also becomes slow. So you have to understand, in any terms, however the technology goes high computing, there will be a restriction that the moment data goes increasing, the access time is going to be complex and decreasing. So what you can say, the bank may keep 6 months transactions, and later on what it prepares the analysis report of the transactions and keeps it in a shorter form. Okay, so for example, if there are 10,000 records per hour, okay, so you can calculate how many records will be there in 6 months, and say 10,000 records per hour can be summarized to one record per hour in a summary form. Okay, so you can understand the size will decrease. So, but it is a summary that you need to relate. So that is called as, so the 10,000 live records is called as online transaction processing, and these summarized records are called as online analytical processing, that is called as OLAP. So data mining can be divided into two parts of data, OLTP and OLAP. So there are certain decision support systems called as DSS. So there are already this DSS supports system applications are available. What are those basically? They are the apps which are having algorithms specially designed to handle OLTP, to handle OLAP, to try to find out queries specialized for OLTP, that is online transaction processing, and certain queries, algorithms have been designed to retrieve queries from OLAP, that is online analytical processing. Today's decision systems have become so much advanced that they are also having algorithms designed that can automatically convert live data to OLAP every hour. Okay, but for conversion of every hour, you need to halt the system. That's why you might have heard about online backup and offline backup. Even your mobile, if you know that night 2 p.m. is generally the mobile systems, they are automatically backed up. right? So similarly, the banking transactions also, when the bank is off, the offline backup takes place. So in the backup, using the database systems RAID levels, okay, you recollect, or you can go through my YouTube video on RAID levels, that is redundant array of independent disks, that is used for backing up your data to maintain reliability, okay, in terms of power failure or system crashes. So at that time, okay, that is generally performed online, and certain things are performed offline. Okay, so generally OLAP systems are also divided into offline backup and online backup, that you need to note. So if you can even design your own DSS systems of converting your online, if your project is having online systems, right? If you're working on banking transactions, then definitely you need to explore the DSS algorithms, decision support algorithms. So what is data mining? Data mining is the automated detection for new, valuable, and non-retrieval information in large volumes of data. Okay, I'll just mail you this PPT, or you can request me on my email ID given. I will share you this PPT of this Wipro. Okay, it's the one PPT itself is covering the entire data mining process, and in a very easier way. Simple example of data mining which I gave you is converting data to information. So if you have got marks of students, you calculate the percentage, okay, with simple formula, and you get the percentage as in information of all the 10,000 students. Okay, but to retrieve knowledge, you need to have some specialized algorithms. Okay, so you can dig a lot of information from the data available. One example I can give you is, suppose you have an automated factory of manufacturing cars. Okay, so cars, you can have different models, and if you have different colors. Now you have to understand that which model and which color, how much model you need to manufacture. So suppose in today's date, black color is mostly used, and red color of the similar model is very rarely used. Maybe 10% of the public is using red color. But how you will understand this? So you need to survey. So you try to fill the forms from the user. Okay, you may have a free survey from the people, where they will fill the forms of their interest, what color of the car they like, what model they like, what features in the car they like. It predicts future trends and finds behavior that the expert may miss because it lies outer their expectations. Okay, now see, if suppose you want to forecast the weather, so there are certain attributes which are related to weather. Say, what is the cloud positions, what is the density, okay, how much level. So if you are in that particular field, okay, or even if you are trying to create a project. Now see, computer engineers, there is a challenge. Okay, computer itself cannot do anything. You need to have that domain specific data. So if you are working on any forecast, you need to first find out what are the attributes related to weathers. Okay, and then in the past, you need to find out that when such attributes had these values, what was the weather that day, whether it was rainy, it was cloudy, it was windy, what it was. So related to the historical information, you will try to predict the future. So nobody is doing some magic in this data mining algorithms or machine learning algorithms. Any data mining algorithms or machine learning algorithms, ultimately you need to identify what was the historical data. On the historical data, what was the outcome? Okay, so if I terms what were the condition attributes, depending upon what was the condition attribute, what was the decision attribute. Okay, and if you have the more the condition attributes and decision attributes, you will be able to design the algorithm based on the condition attributes. So we were discussing about the automation. So if suppose 10,000 people, out of 10,000 people, 9,000 people said that they prefer car of color black. So what a manufacturer will do, it will design, okay, for example, it is manufacturing 1,000 models. So 900 models it will design of color black. And maybe if say 10 people opted for silver, 10 people opted for red. Similarly, he or she will also manufacture 10 cars of red, 10 cars of silver. Okay, maybe assuming the percentage of the total cars that person is affording to manufacture. Why this should happen? Because if say only 10% people like red color, and if you manufacture 90% of cars of red color, what will happen? Your godowns will be with the cars and nobody is going to purchase it, so unnecessarily it will be blocked. So all the business analysts, even a lot of big business giants, they hire business analysts and they are highly paid. Why? Because the decision of the business analyst helps them to have a profit or loss. So if your business analyst predicts that you should manufacture out of 10 1900 black cars, so it will be a hit. But similarly, another business analyst tells you to manufacture 900 red cars, so it will become a blunder. So any business analyst should have a lot of historical data, lot of current survey, because trends keep on changing. Sometimes back, the clothes trends were different. Today, the clothes trends are different. So if we try to manufacture old type of trending clothes, it will be just in the go downs. So similarly, apart from historical data, you also need to have the trending data. And for that, you need to have different type of surveys. So all these surveys, historical data, ultimately when you feed it to your algorithms, they become your decision support system. And based on the decision support system, you try to find out what will be the future trends and the behavior of the system. Okay, so that is nothing magical. The only thing is, the more larger the data you need to analyze, the more accurate prediction you can do it, right? And then whatever the present forecast analysts or the experts are doing, even the astrologers or the tarot cards are doing, they have learned certain algorithms which certain people have designed by lot of survey. Okay, but it's just always understand that a hard computing system can have 100% accuracy, but a soft computing application can have never have 100% accuracy. It can have approximate accuracy. Okay, because you can never predict 100% future. If today the trend is that people are liking black color, the trend can change, but the still you can have certain um, what you can say dependency. Why? Because trend cannot change from 900. It cannot drop of black color from 900 to 9. Okay, it can vary from say 900 to 800, and immediately everybody cannot like red color from 10% to maybe 90%. Okay, it can be from 10 to, it may vary to say 30 to 35%. So it will not be a very big disaster for the big business giants. Okay, but still, to make a note that hard computing means where you can have exact solutions, whereas soft computing applications where you can have approximate solutions. But you can't sit with your hands crossed that okay, you can just go on with any closed eyes the number of manufacturing cars. You need to have a business strategy, okay, where you can have historical data and surveys. And then if the approximation is little bit here and there, that margin every business giant has to take care. So what data mining can do? It can exploit patterns. So as rightly said, data mining is majorly on identifying pattern. So there is a separate subject called pattern mining, okay, where even people try to opt for those as PhD topics or maybe postgraduate topics. Okay, so that's a different topic altogether. But in general, mostly data mining is more concentrating on pattern mining. And it's not necessarily that you should learn a lot of heavy algorithms to identify patterns. Even small children's are you give homework to your children where you give two patterns and you tell them that what is the difference between the two patterns. So they say that this is here, it is triangle shape, this is square shape. So I'm just trying to say that it's very easy sometimes to identify patterns. But why then it's necessary to design algorithms? Because when you are identifying patterns from say 10 samples, your eye can see it, but your eye cannot see 1 lakh of patterns. So that is why you need a computational power, use of computers, where you can identify patterns from large amount of data. Because as we said, that the more amount of data, the more exact prediction you can do. And that's the only way, that's the only reason you have pattern mining algorithms that are based on computer algorithms. But you can do it very easily. What you do as a human, you try to identify patterns from 10 samples. And the same algorithm which you found on 10 samples, you try to feed it on 10,000 samples. And then you see the results. If you get apt results, nothing like it. If you're not getting apt results, try to modify the pattern with some 10 different samples. Okay, that means the 10 samples which you got were not very relevant. You need to have some different variety of samples. Okay, I can give you example of this is, if you suppose try to identify facial expressions of from faces. Okay, so as you know that when you see happy faces, your lips generally expand. Never when you are sad, your lips expand. Okay, whenever you are happy, your lips cannot contract. So it's general criteria that whenever you are happy, your lips expand. So on a face, if you try to image processing, if you try to extract only the features of the lips, you can identify whether he's happy or sad right now. It's very easy. Now, suppose when you are identifying the face, you may try to identify some other type of emotion, say surprise. In surprise, your eyebrows try to change and a little bit of lips. So you try to even add the image processing on your eyebrows. Now see, if you try to identify Indian faces, if you take all 10 samples of Indians, maybe you will try to detect some other decision attribute. But if you try to detect from Japanese faces, their eyebrows are already a little bit aligned differently from Indian faces. If you say Japanese faces, their eyebrows are little bit opposite than that of Chinese faces. So here what I'm trying to say, that maybe your algorithm may be apt for Chinese faces, it may not work for Japanese faces, and it may not work for Indian faces. So if you are trying to analyze a generalized algorithm on say facial expressions, you need to have samples of all the combinations rather. I will suggest you that you should go first one by one. First, try to predict the algorithm for say Japanese faces, then for Chinese faces, and then for Indian faces. And when you become an expert on these three algorithms, then try to integrate say 30 samples and integrate the algorithms on say 30 samples. If it's working fine, then you try to take mixed examples of say 10,000 faces of Indian, Japanese, and Chinese faces. So this is how you have to go step by step in your research. So one is the predictive research and one is the descriptive research. We will see this specifically in our machine learning, where we are going to identify exhaustive research and say heuristic research. Okay, just to tell you in brief over here, okay, descriptive research is exhaustive research. So if you have say 10,000 samples, on each sample you are going to do the mathematical calculations, and then on 10,000 samples then you will try to perform the algorithm on say 1 lakh of samples. But it's not possible to have manual calculations of 10,000 of samples. So in descriptive approach, your sample size is less. So maybe you do mathematical analysis, manual calculations on say 10 to 100 samples, and then you try to perform it on the algorithms designed on the 10,000 samples and say 1 lakh samples. Okay, in predictive, you just directly through your historical data perform the algorithm, design the algorithm, and directly apply it on your 10,000 or say 1 lakh rows. So that is the difference between descriptive and predictive. So in descriptive, you do exhaustive research where you do manual calculations and then you design the algorithm. Whereas in predictive, you try to see the historical data and then you design the algorithm. And what it can't do, it automatically find relationships without user interventions. So data mining cannot be done without using interventions. You need to have historical data that is also from the user of the past, or maybe from the current trends also from the user. Okay, so there has, you cannot just without of your own try to identify relationships. You need to have historical data also to develop relationships. Okay, so without data has to be got from the user itself. User can be anything, an end uh, uh, database also, an external database also, some machine, some external resource, maybe a human, anything can be your data. So ultimately going to the database intervention. So as you can see from this slide, which is our last slide, our next presentations we will be going to one by one on this. So basically machine learning, your DBMS, your visualization is nothing but your HCI, that is computer human computer interaction. Okay, where user try to see your front end first. So the more your uh, front end is interactive, the more your client is interested in your product, and it is more it can use your product. Because if he's not finding it very easy to use it, okay, it will probably end that product and not use it again. So if you have good visualization, image processing techniques can also be used in visualization. Computer vision is another stream in your visualization. So in visualization, your HCI, that is human computer interaction, your machine learning, and your computer vision can be used. Computer vision is a combination of machine learning and artificial intelligence. So visualization can be used in that. So ultimately for that also you have to use data mining. Okay, then applied statistics. So all these statistical methods, okay, starting from your set theory, your fuzzy logic, your logic reasoning, all these statistical mathematical methods are basically used for data mining. Okay, pattern recognition, as said earlier, you need to identify patterns. So the more easily you identify the patterns, the more easily you will be able to design your data mining algorithm. Then parallel algorithms. Why? Because in today's world, everybody is using pervasive computing. What is pervasive computing? Anywhere, anytime application. The two most examples which you are using in your day-to-day life is your internet and your mobile applications. So you are all using, see, even today, we are having this online lecture parallelly. Everybody is using their own system parallelly. But ultimately, we are gathering the information together. Okay, so for parallel information also, data mining algorithms are being used. In your distributed system, synchronization is a very important aspect. So you need to synchronize the data. So you need to have you slice the data, okay, to different computing systems. They then do their computational individually, but ultimately distributed system is working on the same task. The data is gathered again, and then it is uh, that synchronization is done, and it is given to the end user. The product is given to the end user. At the back end, different computing powers are used so that the task is performed faster. So that's parallel computing is being performed. But at the front end, we can see that it is our job is being done independently by a single machine. So for that, ultimately, these parallel algorithms to get it implemented, we need the high performance computers. Okay, because we need to integrate these systems. So even HPC is related to data mining. And last but not the least, the machine learning. So ultimately, if you want to make the machine do something automatically, what you have to feed to the computer, that is also very important. Okay, so what you are feeding, that you have found out from the historical data, this is very, very relevant. I should make computerize this into an algorithm, and then you feed to the machine, right? And then only it will perform it better. So machine learning and data mining, they go hand in hand. Sometimes to design a machine learning algorithm, okay, you need to first do the data mining and find out the decision attributes. Okay, and it is vice versa also. First time to design any data mining algorithm, you need to implement certain machine learning algorithms as well. So as we continue to the other lectures, we will try to more understand the correlation between machine learning and data mining. Okay, so we will stop here with the note that machine learning and data mining, they are the key to our artificial intelligence and our future systems, our pervasive systems. And today the need is that pervasive and distributed systems are the need of the hour, because everybody wants, okay, anywhere anytime applications. Nobody as the past want to go to the internet cafe and check the mails. They want it in their hand. Even today, even mobiles are going to be outdated after certain times, because our mobile is also not with us 24 hours. So wearable devices have come. They want it. Even sometimes we forget where the mobile we have kept. Okay, so if Shah Rukh Khan is having its bungalow, we have heard that Shah Rukh Khan has he has to go from one room to the other in a lift. So probably if he missed his mobile on the third storied room and he comes down, so probably he will get upset. Okay, he has to wait 10 minutes for some servant to get it down, or he may go on his own. So if that wearable device is there as a watch, then this also task is he may not perform. Okay, so the upcoming trends is machine learning and data mining is pervasive system, anywhere anytime application, where your challenge is to convert the whatever systems. Now the mobile is given, the cameras also have become outdated. Nobody is buying DSLRs. Everybody is going for a high-end mobile uh, systems where it has got a good camera. Similarly, now mobiles will also be replaced by wearable systems. So we'll end this topic for today. Thank you for your patience listening. If you have any doubt, you can message or even mail me on the group. Thank you.